Alrighty, and then Jill, you want to go ahead and start it out?
Yep. So let me pull up the slides on my end and present. So I thought it'd be helpful to kind of wrap up what we covered in last time's workshop before we move on to new material. The first one being, we had a question last time about the different types of file formats that can be accepted into QGIS. And I didn't know exactly the answer to that person's question, so I did a little bit more digging. And this question in itself is actually far more complicated than I originally thought it'd be. I thought it'd be a quick Google search to a nice list of different files. However, it was never that easy. And so basically this slide represents all of the different types of information that I gathered from my research. So starting on the left-hand side of the screen, we can see the different extension types for various vector and shape files. So these are going to be consistently the types of vector and shapefile extensions that will be readily accessible in Q that you can easily bring in. They also had a list for different tabular and raster file types that can be brought in. The main raster files, though, are going to be that CSV that I discussed last time. And the main raster is actually as like a JPEG file. But I'd say 9 out of 10 times we're working with vector and shapefile formats. So that's why I listed the most common ones there. Secondly, I was looking at just the general QGIS like manual, and they have it listed that their aim with their software is to have Q be able to upload or import Esri shapefiles. So that's anything from any other type of GIS software. So that could be ARC, that could be Q. Then you also have your map info and microstation files, AutoCAD, PostGIS, Spatial Light, Oracle Spatial, MS SQL, and Spatial Database. So those are the softwares that they list as being their output can be readily accessible and brought into Q. I'm really only familiar with the shape files through other GIS softwares like ARC, and then I'm also familiar with AutoCAD, but potentially maybe someone out there is familiar or uses these other softwares. And then the last thing that I found was that if you're specifically interested in figuring out if a particular vector can be brought into Q, there are a list of like steps that you can do to answer that question. The first one being you can determine what translator you have in your QGIS version. And so basically what I mean by that is you have a GDL OGR that's downloaded when you download Q. And all that does is it automatically brings in the file and it will read it and make it accessible to Q. So if that translator can't read or isn't compatible with that file, then subsequently your Q isn't compatible with it. It's the running machinery for bringing in a file. The other kind of tricky part about that is that this translator is also a software that's constantly improving. There's constantly better versions out. So as you progress in Q, you also are going to see different translator versions. So I looked up for QGIS 3.16, which is probably what most of us downloaded, even 3.18. Our translators are going to most likely be in their version 3 as well. And then once you know what translator version type that you're working in, you can then do a quick Google search and look up the vector formats accepted by that translator. So if you can figure out what translator version you're on, you can figure out what vector formats correspond with that translator. So it's kind of a tedious function. Something that I recommended that you could do as well, that I think is probably just as, effective, is just dragging in the file into your map window and seeing what Q does by default. I think that's a super valid way of trying to work with your data file, because if it doesn't upload at all, most likely the translator doesn't work with it. Another thing you can do is also just do a quick Google search with that extension file and see, I'm sure someone has asked that question that you have too, so I'm sure somewhere on some forum, they'll be able to have your answer. So all of this to say, the file format's accepted by Q. It all depends on your version and it depends on your translator. But that list on the left is going to be what's most likely going to be accepted most of the time. So pretty long-winded answer, but I think we're there. The second thing I wanted to kind of go over and just reinforce before we move on to new information is when we're adding our layers, specifically our vector layers. So those are going to be like our shapefile types. I mentioned last time that our shapefiles are comprised of 3 different files, actually. So you have your shapefile extension, but then you also have your .dbf and your .shx. And if you don't have all 3 of those files in the same location in your computer, when you go to bring in that vector layer, it won't upload because Q is looking for all 3 of those files to make the full picture. And the reason for that, so I wanted to just elaborate on what the function of those 3 file types are and why it operates that way, because it's called a shapefile, right? So you would think that all you need is your shapefile extension. But what comprises the actual like shapefile, the entire like layer itself, is one, that DBF, which is your attribute database. So that .database file, that harbors all of the information and attributes for that shapefile layer. So any type of, so if you're working in polygons, it would store your like area data, it would store like population, whatever that corresponds with your layer information. That attribute table is stored in your database, your .dbf. Then you have your shapefile layer, your actual .shp, and that's where your geometries are going to be located. So that I feel like makes a lot of logical sense, that your shapefile layer is where your actual geometry, whether it's your points, lines, polygons, those are all going to be located in that .shapefile. And then lastly, we have this .shx file, and that is our index file. And what that does, it's kind of controversial, it goes back and forth, but I say the most generalized accepted answer of what that file does is it is the index. So it takes the index of your attribute table and it takes the index associated with your geometries and it links the two. So it allows the .dbf and the .shp to be brought together into this one cohesive file. So I hope that kind of clears up the picture of you need all 3 because one has your attribute table, one has the actual geometries of the layer that you're looking at itself, and then the last one merges the 2 based off of those indexes. And the kind of more convoluted part about the .shx is that it's actually just the first 100 bytes of the shapefile layer. But clearly there must be something else going on such that Q is able to take the IDs from the geometries and then also link that to the IDs in the attribute table. That's kind of where it gets a little bit more technical and outside of the scope of what I think we need to understand. But for the most part, as long as you can remember, we have our database, we have our geometry, and then we have the index that brings those 2 together. And that's why we need all 3 to make our shapefile. Yeah. So with all of that being said, I think we can move on to module 2. So I'm going to stop sharing and pass it off to Alyssa, unless we have any other questions to like kind of really conclude with. Yeah.
Can everyone see any raised hands? So we can go ahead.
Wait, Sarah, what'd you say?
Just said I don't see any raised hands for questions, so you can go ahead.
Oh, okay. Well, I'm just gonna let everyone know that the landscapers are at my apartment today. This is the first time they've been here in like a month, and it's been like all day long, so I apologize for any leaf blowers you hear. So with that, we'll get started. Okay. So we're gonna cover how to create and add layers to your map, work with the attribute table, make calculations using your spatial data, how to select features within your map, join or data joins, and calculate layer statistics. So creating a new shapefile layer is pretty simple. First, you click the layer in the menu button ribbon at the top of the screen. You select Create Layer, then the new shapefile layer. There's also a shortcut to the which is the Shapefile button on the Data Source Manager toolbar. Sorry, y'all. The little symbol is in the shape of a V with like little points along the vertexes. So once you find this button, you will get a pop-up that looks like the image on the slide. So first you specify the file folder and the name you want the new shapefile to be saved as. Then you specify the geometry type, which would be either points, lines, or a polygon. Whichever you pick will, of course, depend on the type of data you're mapping. And then they have no geometry, which will allow you to create a new database file. So after you specify the type of shapefile you need, you will then set the coordinate reference system. Like Gillian mentioned last week, WGS 84 is always a good one to use. The most important thing is that you make sure all of your layers are using the same coordinate reference system. So QGIS gives you the option to add all of the attributes you need. Again, the attribute table displays information on features of a selected layer. Each row in the table represents a feature, and then each column contains a particular piece of information about the feature. So once you've created your layer, it is completely empty and there are no values in the attribute table and nothing is displayed in the map screen yet. So to add your data, your points or lines or polygons, you first enable editing, which is the little pencil symbol. You add polygon feature, and then you can add to the layer by selecting where in the map space you want to use your shapefile. This is useful because if you have a detailed base map, this allows you to trace over an area of interest and create a polygon. Then in the attribute table, you could calculate further, or you could further calculate the area or other characteristics of the polygon. So layer properties is full of information about the layer you are working with, and you can also edit the layer from here. So to access the layer properties, right-click the layer you want to work with, and you should see properties at the bottom of the list of options. Within the Properties tab, you will see menu options on the left, including Symbology, which allows you to play with the color size and display type of the shapefile. Properties will also give you options for displaying the data labels on your map. This is good for city names or anything else you're wanting to identify. And this is also where you'll go if you want to join layers together or a table to a spatial layer, which we'll go over joins later. So like I said before, the Symbology tab will allow you to edit how your layer is displayed on the map and later how it's displayed on your legend. Again, you can change the color and size of any point or line, and for polygons, you can make it an outline or you can fill the entire shape. Basically, this is where you manipulate any layer in your file. If you're using a point or line data, you have options to change the display type of data. A single symbol is great for simply identifying where something is. This option will make every single data point the same format. Categorized gives you a unique format for each value. You want to use a categorized symbol if your attribute table has a column that classifies the data in certain types. For example, if you use a polygon of a piece of land with different types of land coverage, such as water bodies, wetlands, and maybe like hills, you'll want to make each of these land features a certain color. So the symbology property gives you this option with categories. And once you specify that type of symbology, you will then have the option to choose from your attribute table how it is classified. You can then choose a preset color ramp, or you can edit each individual color. So graduated symbols are great for what is known as Choropleth Maps. This is a type of thematic map that provides an easy way to visualize how a variable varies across an area or show the level of variation within a region. These are the most common types of maps you'll see. An example would be comparing populations of individual counties within a state or country. These maps are similar to a heat map, which uses a gradient format of numerical values, but heat maps are typically made after a bit of data analysis and creates a raster file. Choropleth or graduated symbol maps can be made directly from the data within the attribute table. Another feature under properties is labeling your data. QGIS gives you options for single labels and rule-based labels. Single labels are super simple. You just choose which attribute you want the feature labeled as on the map. Rule-based labeling allows you to use formulas using data from the attribute table to filter what is labeled on the map. You can, of course, edit the font you are using and make it as decorative or as simple as you need or want. I've always been taught that you want all of your like features to be labeled the exact same, meaning the same font and font size and whatever capitalization rules you're following. And you always want to be able to read left or right to left, or if you're labeling vertically, up and down. For example, if you're labeling rivers, QGIS will give you the option to curve the label with the path of the river, which is cool, but you want to make sure the audience isn't constantly like turning their head or the map a different way while you're reading the labels. You also want to try and put feature labels on the same spot of each feature. For example, if you're labeling states, you want all of the labels in the middle of each state, which means that your font can only be as big as your longest name of your smallest state. Kind of how you see Mississippi in the corner is the same, the font size is the same as Texas, which obviously the states are two different sizes. There are, of course, exceptions to these rules, but generally this is what you want to consider when labeling your features. So I know I keep mentioning the attribute table, and that's because it's important. So we're going to look at what else can be done with the attribute table. Like I've mentioned before, you can edit any of the symbol and label specific features using the attribute table. We'll get into how you can make new observations using the field calculator. Field length and the type go hand in hand when you create a new shapefile and add to the attribute table. You can specify what type of data you want the field to be, which allows you to specify the length you need for that field. So like I mentioned, you can make new observations using fields in your attribute table. To access the attribute table, right-click the layer you want to work with, and you should find Open Attribute Table about halfway down on the list of options. This should open the table with all of the features in that layer and their corresponding fields or data. Then to make calculations, find the field calculator on the menu bar of the attribute table window. The field calculator will then give you several options to make calculations that can be created as a new field or feature, or update any existing field. The expression window on the left is where you can put the formula in for calculation, and the window on the right will show you the unique values for the field you specify. So another thing you can do with the attribute table is select certain features. This is something I always end up using a lot because it's just super helpful all the time. You can use the field filter option, which is in the menu bar of the attribute table window to select features using a certain field. For example, you can select all the features with a specified state name. You can also use the expression window to make filter equations, meaning if you want to select all of the features with a specific minimum area, you can make an equation saying select all features where the area is greater than or equal to whatever area value you specify. In addition to that, After you've made a selection, you can use the invert tool in the menu bar, and it will deselect what you selected and select what you didn't. Moving on, another feature you can find in the layer properties is the join function. This function uses the attribute table or any non-spatial table loaded up as your data, and it allows you to add data from one layer to another. In order to join two tables, you must ensure that both your data and your shapefile share a field or a common column or value. This is often a name or ID code. In your data table, these identifiers must be unique, meaning one row per name or ID. Joining works by adding fields from your data to the shapefile's attribute table based on matching fields found in the key columns. So you can sort through the attribute table with the select tools previously discussed. However, the data will all be processed when you run any type of processing tool. Queries are a way to basically hide or make invisible or remove the information that isn't relevant so you can look at only the relevant data. You could even do this when you want to create your final map and remove extra information so that only the area of interest is visible. The caveat to this is that you need to do this before you process the data you'll have to save the file as its own separate shapefile to enable it to be edited with only the data of interest involved. So moving on to some basic analysis, QGIS will calculate statistics for you. If you find vector in the main menu bar, you can scroll to analysis tools and click basic statistics for numeric values. This will allow you to choose the field you want to make calculations with. This function will give you the basic idea of the stats, such as area and perimeter of your study site. You have lots of options to do this. So if you select your control points, you can rerun that tool and it will only include your data. Then you can select your experimental area points and rerun them pretty quickly and easily. Well, thanks for listening. Pretty short lecture. So I'm going to go ahead and hand it back to Gillian, and hopefully she'll clarify anything I've left you confused over.
Yeah, so I find with GIS, like, especially most lectures on it seem very like, and here's a tool, and here's a tool, and it becomes very overwhelming. So I'm hoping this demo actually lasts a little bit longer so that we can start to kind of like dive into some of the tools and like reinforce some of what Alyssa just talked about. So I'm just pulling up my QGIS. Everybody should see that, right? I shared my screen, not my Google window.
I see.
Is it pulling up?
I don't see QGIS.
Like my desktop.
I see Google.
Maybe let me try one more time. Screen. Okay. How about now?
Yes. You see QGIS.
Awesome. So first, I'll discuss what we're gonna actually do in our demo, and then I recommend everybody like trying to follow along on your own QGIS on your own laptop. Sarah sent out the one and only shapefile layer we're gonna need. If you didn't download that, feel free to like go ahead and grab that now. And also, like if you did the entirety of the last activity, you actually created that layer, so you're good to go for that as well. So either one way or the other, you'll have your layer file that we're going to be manipulating. But the point of this demo is to walk through first just adding a vector layer again to reinforce that. That's like super easy, quick task. Then second, we're going to create a new layer like Alyssa talked about in the very beginning. And then we're going to fill that layer with attributes based off of that icebreaker poll that we did in the very first workshop. So based on y'all's responses, we're going to fill that attribute with numerical data. Then I'm going to show you a little bit of like the filtering, and then we can even talk a little bit about the field calculator too while that's pulled up. Then we're going to do a join. And lastly, we're going to look at doing some symbology stuff and manipulating that a little bit. So we're going to do a little bit of everything that was discussed today and just kind of deep diving and showing step by step in Q, which I think just really helps reinforce. Okay, so first I'm going to pull up my Q and start a new project. So the way that we go about doing that is just project, new. Now that we have our blank QGIS screen up, the first step that I talked about was uploading that Gulf of Mexico state layer. So the way that we bring in a vector, remember we can do that one of two ways. The first one being we can just take that file wherever it's located and drag it into our map space. So if you drag it in anywhere here, it'll go ahead and pop up. Otherwise, we can do it via the layer tab. So that's layer, add vector layer. And you can also see there are shortcuts for almost any command in Q2. So you could do Control-Shift-V if you want as well. Anywhere to get you to this window. And then once you find wherever you saved your shapefile layer, mine is here. I'm going to click Open, Add, OK, and Close. I'm going to kind of brush across that because I feel like we spent a lot of time on that last time. The second thing that we're going to do now is we want to create our own layer, right? So the way we're going to do that in creating our new layer, very similar to adding it, is you go under layer and now create layer instead of add layer. So under this option, you'll see that there are far fewer like tabs to select from. So we're going to do a new shapefile layer because that's what we're creating, a new shapefile. And so here we have our new window pop up. And here, this is exactly the screenshot from the lecture slides. So here, first under file name, you specify where you want that layer to be saved and under what name. So I'm going to go ahead and click browse. And I have a tutorial folder, so I'm just going to save it in there with all of my other GIS files. And under there, I'm going to just label this demo 2. Whatever you label it is fine. It's just a name. So then I'm going to click save. So now I have my file name and location all set aside. The second order of business is to define the geometry type. So as I specified in the demo instructions, I want this to be a point layer. So I'm going to do this drop down here. And you can see that I could do no geometry, point, multi-point, line, or polygons. So we're just going to do point. But I think it's interesting that you could do something with no geometry and just create an attribute table. Basically, it's almost like you're working in Excel at that point. But we're going to select points. Then I apologize for my phone ringing. And that's going to keep ringing because I'm on the other side of our room. So I think most of that phone ringing's gone. To answer Christina's question, is the encoding important? No, it's not. The defaults for Q are pretty robust so that you don't really have to worry about that at all. Okay, so the third order of business, so we named it, set up where it's being saved, we selected the geometry type. The third thing is setting the coordinate reference system. For the purpose of our demo, everything's going to be WGS84. That's what I did for my states layer that we brought in. So that's what this new layer is going to be. And then lastly, we're going to start adding a couple new fields. So under this second half of the screen, this is all dedicated into adding fields. And there are a couple different ways you can add fields. As with almost anything in Q, there's like 5 different ways to do every one task. So I'm going to show you the main 2 ways to add a field to your attribute table. The first one is I want to add an attribute for the name of the states. So what I'm going to call this is just state. I think that's fine. You can do state, state name, name, anything like that is fine. And then the type is going to be text and length is going to be 80. That's fine, all by default. Your type, you have 4 main different like drop downs that you can select from. Text, it's pretty straightforward. And then whole number and decimal number are like the main other 2. The biggest difference between those being if you did like decimal number, all of a sudden now we can set a precision, and your precision is going to be the number of decimal points out that you want Q to save from. So if you're only working with 3 decimal spaces out, then you could drop that number down to 3. If you need way more than that, then you can select that. But so precision is decimal point out. So you should see when you select whole number, you can't set a precision because a whole number isn't going to have any decimal. Okay, but for state name, that's going to be text. So then our length is going to be 10. That's fine. I don't think we're going to add any state name with more than 10 letters. So that's fine. If you wanted to keep it as 80, that's also totally fine. It really doesn't change much. If you have these large, like just massive files for GIS to process, that's when these lengths and like storage in your layers might become a little bit more critical. But I'd say most of the time, I find that if I set my length to 10 and then I'm like trying to type out a longer name, it just becomes like cumbersome to recreate that attribute with a longer length and copy over all of that information. But if the first time you set it to 100 and you're just really like, if you're really, what's the word? Not robust, but like if you set it out way greater than you think you need, then you have that factor of safety. Okay, so then we've set up that we want a state attribute name. It's going to be text, length 80. We then add that to our fields list, and you'll see it now drop down into our field list name. All of that looks good. So now our attribute table isn't going to just have an ID value. It's going to have an ID value and a state name value, which is great. So we're going to click OK. And like we said in the workshop, this demo is completely blank. When we are looking at our map view, there's nothing associated with demo 2 here in the map space because there's nothing to it. The only thing we've said is that there are 2 attributes, one for ID and one called state. And that's all Q knows about it right now. So now we're going to look into the attribute table of this new layer that we just created. And the way we're going to do that is you highlight that demo 2 so that this is the layer that we're working on. And then you're going to click the open attribute table. So like I said before, it's blank. We have these 2 file names or these 2 attribute column names. What we want to do is add a 3rd column that's going to be number. So we're going to toggle into our editing mode. So that pencil allows us to edit the layer. Then we add an attribute column here under add field. So it's like that yellow star. And then this name is just going to be number or num. And this will be a whole number, length 10. Okay. So all of that looks great. We then can stop editing for a second and just save our changes and get out of that attribute. So now what we have is a blank layer with 3 attribute columns. So this brings us to the point where we want to start filling it with data. So the point of this demo is to create points over each of the states and have each of those points be attributed to the number of people in this conference call workshop that are from those states. And also I apologize for that. We're only looking at the 6 Gulf states. I know we have a couple people from outside of that, so I apologize for not including y'all, but I think this helps just kind of congregate the information a little bit more. But so the way we're going to add information into this map space and into this layer is we go back into that tool, that toggle editing. That pencil is how you allow the layer to be able to be edited. So it's basically almost like an unlock and locking feature. So the second that you're done editing that layer, go ahead and select the pencil, save your changes, and let the layer be. Because otherwise you might accidentally edit it or delete something that you don't want to like edit or touch. So it's just a really good way to like unlock the ability to edit and then turn that back off. But for what we're doing, we want to edit. So click that pencil, and then you're going to add a point feature. So that's just right beside it. And now you should see you have this ability to select where you want your points to be throughout your polygons. So I'm going to select roughly in the center of each of my states. The first one's going to be Texas. So when I left click, it's going to open up an attribute table dialog box. So this box is where I can then set what I want the attributes for that data point to be. So this is going to be my first ID value. So ID is just going to be 1, and that's completely arbitrary. It just needs to be something. So I'm going to give Texas as 1. Then for my state name, Texas. And then for number, I'm going to go in and use that table that I have created for y'all in the demo space. So for Texas, it's going to be 17. So we can go ahead and include that as the number and click OK. And next, we're going to move to Louisiana, like roughly in the center, because that'll make the labels look a little bit more even. Our ID value is going to be 2, state name, Louisiana. And then number, actually, we can either do it here in this smaller dialog box, or we can just click OK and add that all at the end in the attribute table. So I'll show you what that means just so that we can move through this section a little bit more quickly. So all I'm doing is left clicking, adding the next subsequent ID value, the name of the state, and then clicking OK. So we're just going to go through all of those in that way. Now we're in Alabama. Georgia. And lastly, and Florida. Okay. So what I meant by saying we could just add all of that information in the attribute table at the end is we can go into the attribute field up here at the top, that open attribute table button. And here under the number tab, you can see that everything's null except for Texas because we already added Texas's number. But what we can do here is pretty easily go in and just add in the numbers as we go. So Alabama has 11 people participating from there. So we can just select that box and click 11. Then Georgia is 1, so we're going to select 1. Florida has 43. And see, this is a little bit more just like streamlined of instead of going back and forth, you can just add all of your numbers at once. Then we had no one from Louisiana and 8 people from Mississippi. Okay. So now we have like a full-blown mini attribute table. So I'm going to select the toggle editing mode because I'm done adding and editing the information to this layer, and we're going to save it. It'll always ask you if you want to save changes, which is useful because sometimes you'll start editing and realize that like it's just not exactly what you wanted or like something went wrong, and then you can simply just discard those changes. Let me take a minute to look through the chat just to make sure there aren't any questions yet. Okay, so I think we're good. Something I do want to go over quickly while we have the attribute table open is looking at the field calculator just for a minute. So the field calculator, this is like this abacus basically. And so you look at the field calculator and you bring this up and it allows you to do one of 2 things. You can either create a new column in your attribute table or you can update an existing field. I'd say updating an existing field happens a little bit less often than creating a new field, but it can happen. And I think it's pretty straightforward, like what you would do. The functions are the exact same. But basically, if you want to create a new field, you basically keep this checked. Then you can set the name of that attribute column, what type it is, length, precision. So we already went over like basically what these fields mean. And then you have your expression dialog box. And this is where you write the code or like the way in which you want your data to be processed. So let's see, basically, like, let me give you a very like easy example of something like that. So you could go under fields and values, for example, and double click on number and then ×2 and create a field that is just double num. And that would be an entirely new attribute table. So however you wanted to create or manipulate the data that's already in your attribute table, this would be where you do that. Another way that I've used this before is I've also like gone ahead and done like very basic like quadratic functions in here. You can do if statements, you can do or statements. There are a bunch of different, basically, I mean, it's coding at that point. So whatever you can think of on how to manipulate the data that's already in Q, then it can happen in this box. What's really useful is if you're just kind of like rolling through and like not exactly sure what something does, they have, so for example, if you click on something and you don't know what it does or what it means, they have a really great documentation on the right-hand side to explain what exactly that entire like line of code does and like examples of how to use it. The other really great thing about it is you have this preview box here, and the preview box will basically tell you if Q can run whatever set of code you have listed there. So having my preview be 34 means that it ran and it makes sense and Q was able to process it. So say if I did number times anything else, it could be like just text, right? Then the preview goes to expression is invalid, and it'll tell you like, we don't know what you're trying to do. That's not like able to be ran. So the preview box is actually really useful for just knowing if you are like on the right track with a set of code or with what you're trying to calculate. And then all of your expressions and ways that you can manipulate the data are here. Fields and values, I think, is the most useful dropdown just because it gives you all of the attributes that are currently there. So if you wanted to manipulate numbers or whatever else, whatever data is there, then you could do that. But yeah, so this is just a little bit deeper dive into the field calculator to explain what it is, what it does. But it is like that first way of kind of robustly manipulating your data and processing it a little bit more. What's also kind of useful is if you had like a line or a polygon feature, so basically anything other than a point layer, you could calculate the length or area of each individual attribute. And I think that is probably just one of the most useful tools in Q. And that's just doing that $ length, or you could do $ area, which right now it's null because we're working with data points. But hypothetically, if our layer file format was different, it could just output what our area is. So this is the field calculator in a nutshell. The other thing I wanted to show you in the attribute tables is that right now we're looking at all of our features. However, say we wanted to go through and sort through our features a little bit more, we could go under field filter and then select which attribute we're going to sort by. So say we only wanted to look at our states that have greater than 10 people participating. So then we would do number, and we would do number greater than 10. Ooh. Maybe it's double quotations. Let me try. Okay, sorry. So you do advanced filter expression for something like that. So if you wanted to just do like number and look up one individual value, you could do 1, and now you only see the fields that have 1 participant. So this field filter is great for just finding like exact matches. However, if you wanted to do greater than, less than, or do a little bit more complex filtering, that's when you go under advanced filter. And then you can go under number greater than 10. Okay, and click OK. And now we see that there were 3 states that have greater than 10 people participating, and that's Texas, Alabama, and Florida. Okay, so the 2 main ways of filtering, just once more, you have your field editor for individuals directly corresponding with whatever field you're trying to filter, advanced for that slightly more advanced, looking at greater than, less than, things of that nature. So yeah, so your attribute table is an incredibly powerful, useful tool for sifting, sorting, calculating all of your data within your layer. But okay, so I'm just going to exit out of this. Everything looks good on that front. I think the next thing that we want to do now that we've filled this layer full of attributes is we want to join our demo2 layer with our Gulf of Mexico state file.
Hey, Jill.
Yep.
Real quick, before you do that, we do have a question from a couple of folks in the chat. Will it make a difference for future statistical analysis if a column has null, or is it better to put a 0 in there?
I think it's better to have a 0 because null, typically it'll just look right on over it. Another thing I've noticed is, so if you have a whole number, if you use commas, Q hates that. It doesn't know how to process commas. It will not read it as a number anymore. So like those are both really good questions. I think null, it's better to have a 0 than a null. And then the second thing is if you're working with numbers, like if you're adding in your own whole numbers, make sure you don't have any sort of commas. So if you're in the millions, just no commas. It hates that. But yeah, good question. So the next thing we're going to do is that join, because our demo layer, that's where all of our numerical data from our poll is, right? But our Gulf of Mexico states file, that doesn't have that information, but it'd be great if it did. So the way that we go about doing that is just simply right-clicking and going under the properties. Another thing that you can do is just simply double-click on the layer itself, and it'll automatically pull up the property window as well. So like I said, there are probably 2 to 3 ways to do every single task in Q. So you can kind of pick your poison. So now that we're in the layer properties window for our Gulf of Mexico states layer, we then want to drop down to join and click that green plus because we want to add a join. We want to add a vector to this layer. So we are going to join information from this demo2 layer that we just created, and we're going to join it using our state name. And the reason for that is because our Gulf of Mexico states file, they have a state name target field. And basically what I'm trying to say is the join field and the target field need to be the exact same, because that's basically the way that those two values are going to be linked up and find one another. So you don't want it to be an arbitrary ID value unless you know for certain that the ID values in your target field and your join field correlate to the same information. So for what we're doing, we know that our state names correspond to the exact same polygons because Florida is always going to be Florida and Texas is always going to be Texas, right? So that's why we have those two target fields. You could do a numerical like field in which to join and target. Just make sure that you have those indexing done correctly. So yeah, the only other thing that I want to cover with this field is that you have the ability to, instead of just joining every single column in the attribute table, for demo 2, we don't really need the ID column, right? Because that was completely arbitrary. We just added ID values so that we would have them. And then the same with the state names, because we're adding to the Gulf of Mexico state file with the state name, we know that information's already there. So it'd be kind of duplicate to add it. So the only like value that we really want to contribute to this layer is this number column. It's the only one we're really worried about. So it's kind of for ease of information and like sorting that you can just select the number column and click OK. And then we're going to click OK once again in the layer property window. And now how we're going to see whether or not that worked is we have our Gulf of Mexico states layer selected in blue. Now we go back into our attribute table for the Gulf of Mexico file. And if we scroll all the way over to the right, you will see that there's this new column listed demo2 underscore number. So this is the layer name and the layer, the attribute layer that was merged together. So this is great. We have our number or our numerical data in our Polygon now. So now all that's left to do is really just show you the different ways that we can manipulate and show this data visually in the map space. So the first thing I want to do is I'm going to focus predominantly on the Polygon layer for now. So I'm going to make the demo2 layer invisible. So I'm just going to deselect it. So that's just kind of hiding it for now. And then I'm going to double click on the Gulf of Mexico states and go under, let's do labels first, because I'll probably will spend more time on symbology once we get there. So under labels, there's single labels and then rule-based, right? So as we discussed earlier, single labels, you pick your attribute and it'll label everything the exact same way. Rule-based, you can go in and say, well, I actually really liked Alyssa's example of like, if you have like wetlands versus like other different land types, you could make rule-based labeling to say, well, if this attribute is classified as a wetland in this attribute column, then label it this way. Or if it's classified as, I don't know, more like urban, you can label it this way. And then that's all like within the realm of possibility for rule-based labeling. But for what we're doing, we're just going to do a single label because I just want to have the state names on the polygons themselves. So the default already pulled up state name for me. But if it didn't do that for you, it's just the second drop down under value. Then it'll show you an example of what that text is going to look like. Something that I tend to like to do is have a background on my label. Basically what that does is it draws a white box around the text itself. And then what's nice about that is it allows you to see what the text is regardless of the color because you have that white background. Shadow is also a nice touch. I like typically having a shadow. So you can see here the white box and then the shadow underneath it to just allow it to stand out a little bit more. Then there's also your placement. So if you do offset from some centroid, you can then have this quadrant and show if my data point is in the center, this is where I want my label to be, like offset from that center. And then it also gives you X and Y coordinates in which to offset your label. So say you have like a number or like some like specific like star or like say you have a point that you want to label offset from. So if you have a star to indicate like this is where my field site was, you don't want the label directly on top of the star indicating where the field site is. You want it either above or maybe off to the side. So that's how you would do that here under placement. And then really everything else is pretty straightforward. You can manipulate like what, if you want it to be bold, larger, smaller, under just general text. But I think for what we're doing, I just added a background and I added the shadow and everything else is default. And I think that's totally fine. So we're going to click apply. And here you can see kind of in the background that now we have our labels popped up. So that's useful. Next, what we're going to do is go under symbology and start taking a look at the different ways that we can kind of show the data that we have in this layer. So single symbol is what's selected right now, and we have this pink fill for me. And so all of the polygons are different pink polygons, and they're all the same, right? So what we can do is drop down into categorized. And like we discussed in the presentation, this allows us to select a value in which to categorize the data. So for us, just keeping it simple again, like always, we could categorize based off of the state name. Typically with categories, that's going to be more like your text-based kind of like categories. So it's not as much meant for numerical analysis, I feel. Then what you can do is select your color ramp. I think spectral is fine. And then you hit classify. And now what it has done, it has taken every unique value under the state name attribute and classified it together. So with something that has nothing but unique values, categorized can be a little overwhelming because everything's going to be different. But if you were doing this maybe based off of like region, and you had like your northeast, northwest, southeast, southwest, then you would have these groupings of data and this would look a little bit more cohesive. But for the purpose of showing you like what happens when you use the categorized tool, I think this works, it's useful. Something that will also always happen is that it'll have all other values, even if there's nothing that falls into that category. I like to deselect that just so that it doesn't cloud out anything else. So if you had like, I find that sometimes one of the quirks of Q is that you'll have a entire row in your attribute column that's just null everywhere. And like I was saying before, I don't think it impacts any of your processing because it's all null. But when you start doing these like color or categorize things, it'll just do weird things to your legend. So it's best to just deselect it as like a fail-safe just to make sure that it doesn't show up. So to show you what would happen if you categorize based off of state name, this is how that works and how that looks. So each state has a different color. If I wanted to go in and change the color of a state, so for example, if I wanted Texas to be blue because this is kind of an interesting color, that's a weird green, then I can just go in, select blue, and click OK. And then again, you have to apply all of your changes that you do in these layer property windows. But once you hit apply, then we can see Texas is now blue. So this is one way that we could show and kind of like demonstrate the data differently than just one large color. Another way we can do that is based off of graduated symbols. So graduated, like I said, is probably going to be more for your numerical values. So now, and Q will do this for you too, right? So all of these attributes are all numerical because it wouldn't know how to make a graduated like grouping based off of text-based attributes. So it's only going to show you the corresponding attributes that it makes sense to run that on. So the graduated attributes that we're going to look at in particular is going to be that joined layer that we brought in, so that numbers for that pool. Next, I'm going to do reds this time. And so what's cool with the color ramp too is you have so much freedom with the way your information and data is displayed. So if you click on the color ramp, it'll allow you to select your beginning and end colors, which points it will like pick for the in-between colors. Like you have so much freedom for the way in which your data will look. And then when you like click on the different like defaults for the color schemes, I think those are all like perfectly fine and like great to use too. So I'm going to use the red color ramp. The interesting and like useful thing about the graduated symbology is that there are multiple modes or methods for sorting through the data. So Q asks you if you want to have equal count, equal interval, natural breaks. And basically what that means is if they're asking you like, how do you want them to group the data and like what makes like the most sense. So equal count is going to put the same number of polygons in each category. So we'll start with that one. And then you also have classes. So 5 classes will give you 5 different colors. I think because of how small our data set is, 3 is totally sufficient. And as you can see is once I drop that down to 3, it'll show you the ranges for those 3 different values and colors. So if something's white, it's going to be 0 to 5.6 people participating. If it's this orange, it's 5 to 13 and 13 to 43, which is that edge of our data. It's going to be that dark red. And the reason why I did that was so that if you hit apply, you should see that there are 2 polygons in each category, except for the first one, but you know, Q did reasonable, did the best it could. So it has the equal number of polygons in each. You'll also see that because Louisiana had a null value in that attribute, we lost Louisiana, it's gone. So that's just something to take into consideration. But there are other ways you could do it. You could do equal interval, which again, that just makes sure that the numerical values itself is equal. So it doesn't put as much emphasis on the polygons themselves being grouped, like the data themselves having equal numbers. Instead, the values are going to be equally broken. But yeah, so there's a bunch of different ways that you can numerically break up whatever it is you're sorting through. Yeah, so that's basically all I wanted to cover with the graduated symbology. I'm going to drop this back into single symbol and apply just so that we can have Louisiana back. Then the second thing I want to talk about is maybe creating heat maps and what those would look like. So when we were under our symbology for our polygon, right, when we drop down our symbology, it doesn't even give us the option to do a heat map. And that's because it isn't appropriate for our polygon. Like I said before, Q will only give you like the option to do what is appropriate for that layer, which makes sense, right? So heat maps are only used for your point layers. So when we allow our demo 2 to kind of come back and we can see those data points again, and we double click to open up the Symbology tab for it, you can see that we can create a heat map because it's a point layer. Heat maps are more like, they are better for when you have large clusters of data so that you can start seeing like the intricacies of like how the data is changing over a space. So what we're going to be using it for is for those 6 data points. So it's going to look very splotchy and not as like aesthetic as a heat map should look, but it's because we have 6 data points. And heat maps are predominantly going to be for when you have these larger amounts of data with lots of variance in the densities or like numerical attribute. That's when your heat map will look a little bit more smooth, a little bit more like what you would expect a heat map to look like. But I think it's still worth walking through just like how to create a heat map and how like simple it is to create, because I think it's such a useful tool for most people to demonstrate their data through. So like I said before, we are under our layer properties for our point layer. We're under heat map. Then what we can do is specify the color ramp, just like what we did with the graduated symbology that we were looking at for the polygon layer. Then you can also change the radius, which is basically just like how large or small you want your individual data points to expand to. I think the default is fine. It really just depends on how large your area of interest is. Because ours is like an entire state and it's really not that great for heat maps, I think 10 is fine. But you can definitely like mess with that a little bit to get the right like size that aesthetically looks the way you want it to, as far as like how far out you want one point to be able to expand to. Then for rendering quality, I tend to go all the way to best just as a default, because the only time you would want it to be fastest is if you have a lot of data and it's just really slowing down your computer. I've never ran into that before. And I've worked with like some pretty large files too. But especially since we only have 6 data points, you want that rendering quality to be as best as possible. When you go to fastest, you can start seeing the individual pixels and it looks very like granular. And then lastly, and most importantly, you have your weight points by. And that's basically what value are you sizing your, like the size of your data point by. And for us, it's going to be the number of participants. So we're going to drop down to our number attribute column and then just hit apply. And we're going to hit OK. So now what you can see is all we see now are the labels for our Gulf of Mexico states file, which is peculiar, right? We completely lost that polygon. But if we turn off that demo 2 layer, it's still there. The polygon hasn't gone away or done anything. The only difference is that demo 2 has effectively covered it up. I actually think it's really interesting that the labels are still there, because I've never actually ran into that. Normally it just all completely disappears. So when you're working with heat maps, I find that the easiest workaround for this is to have a line layer that sits on top of your heat map. And then that way you can see through the line layer into your heat map. Because if you are using just your polygons, as you can see here, there's no polygon to be seen. You can't really see your base map anymore. It's gone. So what I mean by that, and this is actually going to take us into our processing toolbox a little bit. So this is kind of a teaser for next time's workshop. But it's actually kind of funny because normally if I were to have y'all do this, I would have you grab the coastlines layer from Natural Earth and just bring that in, and then that's sufficient. However, because Natural Earth is down, we're going to do a little bit more processing, which is still like super straightforward, pretty basic. And yeah, so just a little bit more processing. So what I'm going to do is turn off this Gulf of Mexico states layer. We really don't need it anymore because it's not really helping us. You know, it's not giving us really any information or showing us where in the world this data is for our heat map. But what we need to do is go into our processing toolbox. I keep mine on the right-hand side of my screen. However, like I said before, if it's not where yours is currently located, you can go under View, under your panels, and select the processing toolbox, and then that shall bring it up so that you can be able to see it. If you don't see it at all, then you need to go under Plugins, Manage and Install Plugins, and look for the processing toolbox there. Most likely, what has happened is that it has deselected. Sometimes it does it by itself. Sometimes it accidentally hits. But one way or the other, you need to make sure that that processing has a check mark beside it so that it is available. And then the third way to get to the processing toolbox is you can go under processing and just select toolbox. But if your plugin is deselected, you won't find the toolbox under processing, and you won't find it under view panels either. So if you aren't finding the toolbox anywhere, go under your plugins and try to find it there. But so hopefully everyone can bring up their toolbox. And this is going to be the main subject of next time's workshop. So I'm going to be just running through all the different types of tools and different like ways that we can analyze our information once it's brought into GIS. Because now we've talked about adding layers, we've talked about creating layers. We have a good idea of like how to manipulate them in the attribute tables. So now we can do a little bit greater spatial processing. And that's what the toolbox is for. So it's basically your toolbox full of spatial processing tools. So now that we have our processing toolbox pulled up, what we want is to create a line layer that looks just like our polygon layer here. And the way that we can do that is just simply by going into the search bar of our processing toolbox and typing in polygon to lines. And for me, it's under my recently used, but if you haven't recently used it, which probably most of you haven't, you can go under your vector geometry and find it there as well. But so you're going to double click on your polygons to lines tool. And so then you click your input layer. And there's only one layer that you could input because it takes your polygon, and we only have one polygon right now in our project. So I'm going to select my Gulf of Mexico states layer, and then I'm going to make sure open output file after running is selected. Otherwise, it's ran and done it, but sometimes it'll save it in some like very obscure place in your laptop that's hard to find. So it's always a good idea that if you have the option to open whatever it is it ran after it's run, to select that as like a baseline, like always do that. But yeah, so this tool is super easy, and even like the description, pretty cut and dry, converts polygons to lines, as the name says. So all we're gonna do is click run, and it'll think about it for a second. And now you can see we have a new layer, and it is called lines in our layer toolbox. And if you think about this tool in particular, is that when we had it pulled up, it creates a temporary layer, right? So that's what this is talking about here. And what that means is when we exit out of Q, this layer is going to be deleted. And Q will remind you of that right before you go to shut down your project. And it'll even ask you like, oh, you have temporary layers. What do you want us to do with them? And most of the time I'd say it's fine to just throw them away, and you can always create new ones. But if you wanted to save this layer because you know you're going to use it in the future, that's when you have the ability to kind of toggle into your computer and save that file in a specific location. So like I said, if you wanted to run this and save to file, then you can pick where in your laptop you want it to save and keep it as a permanent shapefile. But for me and the purpose of this tutorial, I'm fine with it being a temporary layer that's going to disappear after. Another thing you can do if you don't want to rerun it, but you do want to keep this layer, is you can right click on the layer itself and simply go under Export, Save Feature As, and this will allow you to save your vector layer somewhere within your computer. So once again, you have the 3 dots that allow you to browse through your computer, name it where you want it to be located, and then you can save it as a shapefile. What's also nice is that when you export, it gives you the ability to output in a number of different different file extensions. So if you knew you were about to bring it into AutoCAD, or if you want it to be saved as a Excel file, then that's all possible here. Okay, but like I said, I'm going to keep mine as just a temporary line layer. I'm also going to go in, and right now my line is this dark orange color. I'd rather it be black because my heat map is black and white. So I think for ease and clarity, I'm also going to keep my line layer as black and white. So what you can do, like I was saying before, you have so much freedom and flexibility with the colors and the way things are displayed in Q. So you have this color ramp, you have the color wheel, you have all of these different sliders. This third one I think is most useful because it gives you a list of standard colors. So I just want black, right? So I can just click on the standard color for black. But then they also even have the drip tool that allows you to just go to your map and select the color you want to bring in and mimic as well. So there's just so many options for colors. But again, I'm just going to select black, click OK. And then I'm going to click OK again to make that line black. I'm going to make this layer invisible. And then I'm going to show my demo2 file. So what I kind of want to reinforce with this is that with this heat map, if my line layer was underneath the demo2, we run into that same problem of the white background from the heat map is going to overshadow any layer underneath it. So that's why we went through the trouble of creating this line layer, because the line layer is only the outline of the polygon. So now we can see the data underneath it, and that white is really just, it kind of looks like the white of the polygons themselves. I've done a lot of digging about this kind of problem with heat maps because it is truly a quirk of that function, and I have not really found a great way to make your null value clear or transparent such that you can see underneath it. Most layers, so I'm going to go under layer properties, most layers allow you to state how transparent you want those colors to be. And that's a partial workaround, but I'd say that it doesn't give you the full answer or solution to this problem of the white background just overshadowing everything underneath it. But yeah, so like we were originally doing, we were just looking at the heat map for the demographic within our workshop. And you can see here that Florida is pretty dark, with the second darkest probably being Texas. And then we have 2 lighter spheres in Mississippi and Alabama. And as I kept driving in, this isn't exactly the best data set to run your heat map on. Really, when I'm thinking about it, graduated probably makes the most sense. And I'm doing this very quickly under our point layer because I want to show you the difference between doing this in a point layer versus a polygon layer. So if I just click number and I classify with 3 different groups like I did the last time under equal count, we can kind of remember what that looked like. And now we see that we have just these different data points, these individual dots that are different colors. So that was kind of where it's really useful that we merged that data with the polygon layer, because now the entire polygon turned red versus just that one individual point. But if we wanted to change the shape or the size of that individual symbol, we could do so by just clicking on it, and it'll open up this symbol dialog box. And we can change the size, we could change how it looks, and you can make it any type of marker you want. So simple markers are obviously going to be more like your squares, your stars, But you can even import symbols if you wanted. If you had SVG files, you could create your own symbol and bring it into Q to use as your own like personalized marker set. But there's so many different types of markers that you can work with. So like SVG markers are the slightly more complex ones. So like I said, now you have all of these different groups of symbols to work with that could identify anything. So I mean, if you were looking at wildfires, there's a marker for fire. So yeah, I'm going to exit out of all of that and click OK. And I believe we've walked through adding in our Gulf Mexico state layer, creating our new point layer, filling it with that data from our poll. We looked at our attribute table and filtering. We looked at our field calculator a little bit. And then lastly, we did our join and then toggled through a couple different options with the symbology. And the main takeaways from symbology is that you have categorized, which is a great way to categorize your information based off of like text. Then you also have your graduated, which is great for numerical data. And then lastly, we have our heat map, which is great for these larger amounts of point data and information. And like I said a couple seconds ago, we're going to be looking at the processing toolbox and moving towards this idea of geospatial processing and different ways to manipulate the layers once we have them brought in. But I think we covered a lot, and we did quite a bit with this data. Did anyone run into any like huge issues, huge problems? Are there any conceptual questions? So we're kind of getting to the end of what I was hoping to cover. Okay, not seeing anything in the chat. I'll just like talk through the activity. But again, feel free to raise your hand or type in a question or just shout it out. Because you can also share your screen with everybody if you feel comfortable doing that, if you're stuck on something. But if not, if everyone got it and everything's going smoothly, for your second activity, what I'm kind of tasking you to do is to create a heat map of the US Census data for the population greater than 75 years old. And then you're going to, based off of that heat map, start to look at the states with the maximum and minimum number for that sample set. So you're looking at population of people greater than 75, looking at where that is spatially distributed, and then you're going to do that again for people underneath 19 years of age for that Gulf Mexico state file. So you're building off of what you did with activity 1. The only difference is you're going to be creating a heat map. You can also go ahead and make that a graduated map in your Polygon layer too, just kind of like really challenge yourself. But I think the main challenge with this activity is sorting through the information to only include those greater than 75 and then redoing that for those less than 19 and being able to see spatially where those max and minimum numbers lie. So, and like always, if you get stuck, you can go under the website with all of the different all the different file types that I believe is in our Eventbrite and that Sarah shared. And you'll be able to see the video walkthrough of like me walking through step by step how to do that and kind of like what I mean by all of that. Sarah just posted it, so that's awesome. But yeah, so that is our activity 2. It's pretty similar to what we just did here. Yeah. For the question asking, does it read scientific notation? No, it doesn't. As far as bringing in information in scientific notation, I don't believe it does, unless it depends on whether or not the CSV reads it in as an E versus a .000, you know? So if when Excel transfers it over to the comma separated, I believe it would probably be okay and save as a 0.00 whatever value. But as far as like if you're just typing in E, I don't think Q has like that ability. So just be careful with that. As far as like any kind of like numerical input or output, try to be as clear with it as possible. And when in doubt, that like attribute preview tab is super useful in like allowing you to see if that's something that is compatible with Q. Because that problem with the commas is something I've kind of just discovered. I was having this huge problem for forever with this one data set, and I couldn't figure out what was wrong. It all looked fine. And then when I finally got it to run, I realized it was just because when I uploaded the data, it had commas in it. So just be careful if you use scientific notation, know that that could be a source of error and to tread lightly. Yeah. If there aren't any other questions, I will see y'all in the next workshop.
There's one
if
more
you have,
question, Joe.
Yeah.
Oh, I think Alyssa might have just answered it. So Nora wanted to know, can you draw a shapefile in QGIS from gridded data? And then it looks like Alyssa says that there's a contour plugin. So if y'all want to elaborate on that real quick.
Yeah, and that's pretty much exactly what I would do. So you could, actually, I think we're going to cover that in the next workshop. There is a contour plugin that is great for topographic data specifically. So when you bring in your raster or if it's like a .tif file, the contour plugin will create contours at whatever interval you set it to. However, if you have this like gridded data, if you want, what you can do is you could just draw your coastline. If you have data points that go across the different like coastlines that you're interested in too, there's points to lines that creates your contour lines. So basically what I'm saying is there's, again, like 4 different ways you could go about solving that. The contour plugin is great. Points to line is also great. When you bring in the information, it really just depends on how you bring in that topographic data. But yeah, you can also just go ahead and draw it in too if you know exactly where it's located. Kind of like what I was alluding to last time, we did a project that looked at erosion from GIS satellite data, and we just drew our coastline, and that was sufficient for what we were doing. And we were able to pick up with like rather like good enough precision to state like half a foot like erosion over certain time intervals. So like depending on the clarity of whatever you're working on, if it's a satellite image, if it's topographic data from like a raster file, it's really all about your input is basically what I'm saying.
Yeah, this is a paleo, like a paleo like a modeled output for paleo data for like paleo elevation and bathymetry. So trying to find the coastline of like 15 million years ago from that. That's what we're trying to do.
So what exactly is the like file type for that then?
I mean,
or is it
the file is a .nc file.
okay.
But I could extract it and but it would end up being a gridded like a gridded data set for like discrete time points.
Maybe could you maybe email it to me? Could I look at that?
Yeah,
because I'm having a hard time like understanding exactly what it would look like, and I also don't know what .ncs are like as well. But
yeah, I've usually like .nc, like that's something that you can do in MATLAB, but MATLAB's like mapping capabilities are really clunky and not the greatest.
I gotcha.
Yeah, I'd have to, yeah, NetCDF.
Oh, okay.
I can send you the data set link.
Yeah, it seems like Chris said that you can extract each time slice as a raster, and if you can do that, then once you have your raster, you can run it through the contour plugin, and it sounds like that would probably be the way to do it.
Okay.
Yeah. Cool.
Yeah. Okay. Thank you.
Yeah.
I can also send you the link if you're curious.
Yeah, I mean, I'd be down.
Thank you.
All right, any other questions for Joe or Alyssa? Anyone? All right, I don't think so. All right, so I guess that will conclude today's session. And yeah, so we'll see y'all next week.
Yeah.
Bye, everyone.